Hello, guys. Yesterday we had a chance to introduce day five, which included a brand new form of an equation, point slope form. And we said this is a new way we can write an equation and it can help us graph an equation is by having it in this form right here. And so we had talked a lot about slope-intercept form and what we got from it. We got a slope, the line slope, and the y-intercept of that line. So a point where the line crossed the y-axis. Point slope form is a little bit different though. It was y minus y1 equals m times x minus x1, where x1 and y1 was our points. It could be any point on the line. It doesn't have to just be the y-intercept. And then, of course, m is our slope. And we see that these two forms share y, m, and x together. But we replace, of course, that becomes a number, that becomes a number, and that becomes a number based off our points and our slope. We had a chance to see that in action. x1, y1, here's our slope. You plug those in. y1 goes there, x1 goes there, and then slope goes right after the equal sign. And you just had to watch out on numbers 2 and 3 because anytime you have negatives, we see that it's already a minus for both of those. So you plug a negative in there like -1, y minus y1 would become y minus -1. That really becomes y plus 1. Same thing here, x minus -2 really becomes x plus 2. And so now, I know some of you can skip this if you were here in person. You've already done this, hopefully. So you can kind of breeze through this if you have already done this top part. But guys, we want to be able to graph these equations if they're written in point slope form. So again, we look and say, okay, what are they giving me? Well, they're giving me a point and the slope. Let me see, our point will be here, and our slope will be there. It always comes after the equal sign. So I see a 3 here, and I say, oh, wait, m equals 3. That's our slope. And actually, if we want to make that into a rise over run, we can put that over 1. Now our point, this is the tricky part right here. This is the tricky part. So we know points are made up of x's and y's, so we're looking for x1 and y1. So x1 should be at the very back. Oh, and it's minus, which is perfect. So that means that x is a positive. That sign is what it should be. The only way a sign changes is if we insert not a positive, but that should be y minus y1, but a negative. If it's y plus 1, we must have done a double negative. That 1 is really -1. And so remember, if you want to plot a point, it's not the same thing as slope. We go x, then y. So we go, let me do this so you guys can actually see. I don't know why the copier does not like to print these coordinate planes. There's x, there's y. There you go. So we go 2 to the right and then down 1. And then from there, you're using your slope. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. Up 1, 2, 3, over 1. So we've got ourselves a nice line. You also could have gone down 3, 1, 2, 3, left 1. That also would have worked. So what I'm going to let you guys do in pencil, I'm going to let you guys, if you haven't already, try 5 and try 7 for me. Go ahead and give that your best shot. Let's see how you guys did. So slope's going to be -1. I put that over 1 so we could do some rise over run. And then our point is going to be x1, y1. The problem is that's a plus when it should be a minus. So we know that really is a -2. Double negative, turn that into a plus. And then y minus 4, that's the way that should be. So that's a regular 4. We plot our point, left 2, that's -2, and then up 4. And from there, you're going -1 over 1. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. You also could go up 1, left 1, up 1, left 1, You got a line there. And number 7 is even nicer. They go ahead and give you the point and the slope. They don't even make you pull it out of the equation. So -1, -3. We go left 1, down 1, 2, 3. Then we're using our slope. Up 2, right 1, up 2, right 1. You can kind of see that keep going. All right, guys, on to the back page. Okay. I'm going to let you guys try number 8. And then I want you to look at 10. And again, if you can't read this, I'm sorry, it didn't print the best. This is y plus 4 equals -5 times x minus 1. So if you can't read that very well, that's what that said right there. So try number 8, and then go ahead and tell me on number 10, describe what we know about the graph of a line represented by this. So you're going to describe what we know about the graph of this equation. So go ahead, guys, number 8 and number 10. Okay, so number 8, they give us this point, -3, -2. So we go left 1, 2, 3, and then down 1, 2. There's our point. Now we're going to use our slope. Down 4, right 1, down 4, right 1. You also could go up 4, left 1, up 4, left 1. And as far as describing on number 10 what we know about this equation, it's written in point-slope form. So we can see that. So we know we should get a point from it, and we should get a slope from it. Those are 2 guarantees. So we look and we say, okay, point-slope form is y minus y1 equals m times x minus x1. M, oh, right there. So our slope is -5. In other words, we got a line that's going pretty sharp downhill. We got a downhill slope, pretty big time. Now, also, we get a point from this. So our line passes through points. Let's see what point it passes through. So x1, y1. x1, y1. So that would be 1, because that's a minus. And then we got, should be y minus 1. Oh, but that's a plus. Oh, but we know why, because that y1 is really negative. So we know what the graph looks like, we know what its slope is, and we know a point that it passes through. Nice work, guys. Now, I really like these next couple sections. Check it out on this one. We're going to write an equation in point-slope form when they give you the line. So again, the key here is point-slope form of each line they give us. And the cool thing is, I want to make this very clear. We've got 3 points on our line. Take this into heart, guys. You could choose any x1, y1. You could choose any of these 3. You could go with this one, you could go with this one, or you go with that one. And I'm going to give you an example of each. So for example, this point, that is -2, 0. This point right here, that is 0, 1. And this point here, that is 2, 2. We could go with any of those. I'm going to go with this one. So you could choose any of them, any work, any of these 3. I'm going to go with this one. So we're going to have, that's our x1, y1. Now we need the slope. So to find the slope, we got to do some rise over run. So I'm going to start with this point. Looks like we go up 1 and then over 1, 2. So slope's going to be up 1 over 2. So I've got my slope, I've got my x1, y1. I'm ready to go. So y minus y1 is 2 equals slope 1/2 parentheses x minus x1 is 2. And voila. But guess what? We could have chosen either of those. So you could have gone with this and had an equation that looked different, but is still correct. Like, for example, we could have gone y minus 1 equals, slope still the same, 1/2 x minus 0. That's also correct. You could have made one for this one too. They're all correct. So I'm going to let you try part B for me. Then we'll just have one section left after part B. All right, check it out, guys. So we could have chosen either of these points, either -2, -1, or 1, -2. We had kind of 2 points to choose from here, and I actually gave you both answers. You could have had this or this, depending on which point you chose. Our slope was down 1, right 1, 2, 3, so that didn't change for either of them. But depending on which point you went with, that affected your x1, y1, x1, y1. It's like with this one up here, I went with -2, -1. And with this one down here, I went with 1, -2. All right, last thing, guys, and then we are done. But I saved the toughest for last. So we got the toughest stuff for last here, so stay locked in with me. So we're going to write an equation in point-slope form that passes through the given points. Then we're going to write that equation in slope-intercept form. Ooh, this is going to be a little tricky. So we're going to write an equation in point-slope form and then transform it into slope-intercept. So we're going to start with point-slope. What are the two things we need? Well, y minus y1 equals m times x minus x1. Looks like we need a slope and we need points. Well, the good news is we already have 2 points to choose from. I'm going to make it easy. Let's go with 5 and 1. Actually, you know what? Let's go with 0 and 2. That's our x1. No, I'm sorry, guys. That's my bad. We'll call that x1, y1. We'll call that x2, y2. And why is that? I'm sorry about that. Well, they give you 2 points. Also, don't we need to find the slope? And if you need to find the slope, y2 minus y1, remember that? Over x2 minus x1. So to find the slope here, we're going to go m equals 2 minus 1 over 0 minus 5. 2 minus 1 is going to be 1. 0 minus 5, that's going to be -5. So then we've got -1 over 5 would be our slope here. I never like to leave the negative there. I'm going to move that up top. Now, which point, I know we labeled them x1, y1, x2, y2, but you could choose either point. And which point would you like to choose for our points here? I'm going to go with, I'll go with the one we went ahead and labeled x1, y1. You don't have to. I'm going to go with this point. So we've got y minus 1, that's y1, equals our slope, which is m, -1/5, parentheses, x minus x1, x minus 5. Hey, that's point slope. You did it. That's point slope form. But here's the problem. Then write the equation in slope intercept form. Okay. We know slope intercept form. That is y equals mx plus b. You notice how this form slope intercept has the y by itself? That means we're going to need to get the y by itself as we transition from this form to here. You also notice there's no parentheses in this form. That means we're going to need to distribute and take care of y1. So we're going to need to distribute and take care of that right there. So let's see what happens. So we're going to distribute negative 1/5. So y minus 1 equals, now negative 1/5 times x is negative 1/5 x. Negative 1/5 times negative 5. If you do that in your calculator, that actually works out to be a negative times a negative is a positive. 1/5 of 5 is 1. So hey, we're close. Y equals mx plus b. We're close. The only thing is y needs to be by itself. Y right now has a minus 1 over here. Let's add that 1. Y equals negative 1/5 x. Check it out. Plus 2. Y equals mx plus b. Hey, so you just distribute and then get rid of the y1. That's all you're doing there. Distribute, add the 1 over, or take care of it. If that had been a plus, we would have subtracted it over. So your homework, guys, I want you to try part B for me. I'll be your homework here. Let's go ahead and give that your best shot, and you'll be able to see what that is when you get done tomorrow, or when you get done hopefully today. Thank you.